Hello, everyone. Welcome to our webinar on building a comprehensive security solution with AWS Security Services. By way of introductions, I'm Moon Hussain, Principal GTM Lead for AWS Network and Application Security. I'm based here in San Francisco. I've been with AWS for about a year and have been leading product management for cybersecurity for about 2 decades. And I'm joined by a senior solutions architect, Michael Lighty, based in Atlanta. Michael, would you like to introduce yourself?
Sure. My name is Michael Lighty. I'm a senior solutions architect, as Moon mentioned, and I focus on some of our network and application protection security services.
From an agenda perspective, on this next slide, Michael and I will tag team to cover the why. Why do we need these automation techniques? The what, by describing what these techniques are, by describing the underlying use cases, and then the how, in terms of how to accomplish the automation techniques that we're about to describe. Moving on to this next slide. Now, what you'll find is that, the threat landscape today composes of attacks that are multi-vector relative to the techniques that are used to exploit vulnerabilities. Now, in speaking with customers, it's evident that in order to detect and protect against these threats, they are increasingly identifying with the need for more of a holistic view and a methodology for how cloud workloads are to be protected. There's also a realization that security services are designed to detect and remediate events and can't operate in silos, but rather they need to work synergistically with each other, these services working together to basically expand the footprint of what can be seen and subsequently mitigated. So today, Michael and I would like to share with you some automation techniques that will allow you to extract added value from your AWS security deployments. We will not necessarily be diving deep into any one service, but rather will expose methods that customers are utilizing today to create that multiplier effect brought about by tying together multiple services to deliver that layered defense. But just to level set, this slide highlights the spectrum of services across our services domains, with that sliver in the middle speaking to the range of security services that are used to protect the network as well as applications. In our discussions today, we'll be getting into how these services can contain the propagation of the threat vectors that I just mentioned that are detected across different security services. But before we get into the target use cases and the techniques for automating the interaction between the services, let's spend a little time talking about the benefits that the integrations bring to our customers. So moving on to the next slide. And the following slide, we'll get into the first benefit. So this first benefit is related to an ability to detect IOCs or indicators of compromise for services that are outside of that sliver that we showed you earlier, which is the network and security application set of security services, but will utilize the reach of network and application security services to perform the remediation. In this second benefit that we have in the next slide, this deals with the sharing of threat intel. So when you consider the more sophisticated multi-vector threats, you can look closely at the kill chain to discover that there are discrete phases in the attack. The use of newly formed domains, the use of a spoofed IP, the opening up of a command and control channel, the downloading of nefarious files, the exploiting of an application vulnerability on a web server, etc., and so on. So there's no one silver bullet that has the ability to detect all aspects of the kill chain, but rather we need to sort of leverage the detection capability of multiple services and then share the threat intel to broaden the aperture of what can be detected. In this next slide, the third key benefit is related to compliance and the confidence level of taking response actions to respond to compliance violations. So we hear time and time and again that IR, incident response specialists, are nervous about taking response actions for events, for the fear that the event could be based on false positives and hence have the potential of disrupting legitimate services. So they want to be doubly sure that the event is indeed related to nefarious activity. So one way of increasing the catch rate in reducing false positives relative to compliance is to corroborate detection across different services. And once a threshold has been exceeded relative to a confidence level, the IR specialist can then choose to confidently convict a compliance-related event and execute the remediation action. So this benefit talks to the specific scenario. And in this last benefit on this next slide, it's one that is more commonly understood and is related to centralized management and monitoring, which highlights the benefit of pushing consistent policy across services, both AWS and third party, and then to work in tandem with other security services to consolidate and correlate events. Now, with these benefits that we've summarized, now we'll get into the part of the presentation to call out very specific examples, and then Michael will highlight the mechanism by which each example can be accomplished. For this first example, we have a case where a resource in a VPC attempts communication to a suspicious host. Now, this suspicious host could be out in the internet, and the ability to stop such a connection could easily thwart things like exfiltration attempts or even communications through a command and control channel. It deals with the customer's ability to detect an event from a variety of sources in GuardDuty, which, as you know, continuously monitors workloads looking for malicious activity. Now, the detection sources may not be the same mitigation points to remediate that activity. That's where network and application services come in. So in this case, the goal is to remediate on network firewall by blocking the source IP of the threat that was detected by GuardDuty. So here, Michael will now highlight for us how the alerts from GuardDuty can influence the block actions taken on AWS Network Firewall. Michael?
Sure. So what we have here is a more elaborated workflow from the previous diagram that I'll walk through. So our first step here is that Amazon GuardDuty detects something unusual in terms of potentially malicious behavior in the Amazon VPC. And some of this behavior includes with it communication to a remote IP address. A common one you might have seen before is something like a backdoor command and control activity that's detected by GuardDuty's analysis of the VPC flow logs. GuardDuty then generates some findings. These are usually in a JSON format, and that finding will include additional details, things like such as EC2 instance ID, where the traffic was sent from. Step number 2 here, Security Hub is going to ingest these findings, and it consolidates those with other findings across other AWS security services. And in addition to this, it will also publish any of those findings into its EventBridge bus. And step number 3, Amazon EventBridge is going to have a pattern match within it that's looking for specifically GuardDuty events that have this sort of pattern, and a remote IP address is part of the finding. And it's going to route any of these type of events to a designated target, which in this case will be a step function state machine that manages our remediation workflow. In step number 4, that step function state machine kicks off. It's ingesting the details of that Security Hub finding, and now it's starting this defined workflow for inserting the malicious IP address into a network firewall policy that can block it. The first step in that workflow is going to be to record that remote IP address into a DynamoDB table after first checking to make sure that that IP address doesn't already exist there. It's also going to include a timestamp recording for when that activity was observed, and that timestamp can then be used to remove entries from that table after a specified period of time. So we don't want to keep, IP addresses can be fairly ephemeral, so we probably don't want to keep them forever. And the default, which is configurable, is a 12-hour period of time. In step number 6, we take the IPs from the DynamoDB table and they get inserted into a block response within the network firewall that blocks all network activity destined for that list of malicious IPs. In step number 7, we then, if our workflow is successful, nothing's gone wrong with the state machine, we'll generate an SNS message that indicates that success. And if something goes wrong with that, a step number 8 that's not shown here would be we would actually send details, including any error messages associated with any failures.
In the second use case, the goal is to utilize DNS filtering to remediate what was detected in GuardDuty. So Amazon Route 53 Resolver DNS Firewall is a managed firewall that you can use to block DNS queries that are made for known malicious domains and to allow queries for trusted domains. It provides more granular control over the DNS querying behavior of resources within your VPCs. And in this use case, when GuardDuty detects communication with the malicious domain, it initiates a series of steps to orchestrate the remediation response through a defined workflow. Then DNS Firewall adds the suspicious domain to the deny list or alert list. And finally, GuardDuty notifies the security operators of the attempted communication. So Michael will now step us through the details of this automation.
So the automation workflow for this interaction is going to be very similar to what we just looked at with Network Firewall and GuardDuty, except in this case, the big difference is going to be that we're now going to look at GuardDuty findings that have to do with a domain name, or what's sometimes called a fully qualified domain name, or FQDN in acronym form. So here's the steps we're going to follow. The first thing is that, again, GuardDuty is going to generate the initial finding, which involves communication from our workloads to some sort of suspicious domain. Again, that might also be referred to as an FQDN. Security Hub is going to ingest the finding that is generated by GuardDuty, and then again, it's going to publish these into the Amazon EventBridge bus. Within EventBridge, there's going to be a pattern match. It's looking specifically for GuardDuty findings that have an FQDN as part of the finding, and it will forward these on to our step functions machine, similar to how we saw in the previous example. That step function machine kicks off a defined workload for updating our Route 53 DNS firewall. Again, the first step of that workflow is going to be to use a DynamoDB table as an interim step to manage our list of malicious domain names. And we'll check to see if that state machine is going to look and see if we have a domain that already exists in our table. And if it does not exist there yet, we're going to add it to it. In step number 6, we'll update the list from that DynamoDB table into the Route 53 DNS firewall list, which is aligned to the block action that we want to take as a remediation response with the DNS firewall. And again, if everything's successful, we'll send out an SNS message with the details of that success. If there's any sort of failure, we'll also send out an SNS message that has details related to any sort of error messages that we saw.
Great. In this example, GuardDuty will be working with AWS WAF, which is a web application firewall that helps protect your web applications from common web exploits that could affect things like application availability, security, or excess resource consumption. AWS WAF supports both managed rules as well as a powerful rule language for customized rules. In this use case, detections of malicious sources trigger step functions in Lambda to create web ACLs on AWS WAF, which are configured to trigger rules that can block nefarious activity. So Michael, any details on this one?
Yeah, so again, we're going to start with a GuardDuty alert as our kind of first step here. In this example, we're going to have an integration here between both WAF and GuardDuty that also corresponds with network ACLs, or sometimes called NACLs. So the first step, similar to the other examples we've looked at, is going to be GuardDuty generating an alert. Some examples of the types of GuardDuty findings that we're going to be looking at and querying through for this are unauthorized SSH or RDP brute force attempts. We'll look at port probe alerts in GuardDuty that are associated with reconnaissance or scanning attempts against our workloads. We'll look at any sort of Tor IP events that indicate communications with the Tor network. We'll also look at communications with known black holes or Trojan drop points, which would again indicate some known malicious activity. So our first step is to have GuardDuty identify one of these alerts. We'll have in step number 2, we'll have a CloudWatch event that's configured to filter for these specific selected GuardDuty finding types. In step number 3, we're going to have a Lambda that gets evoked. And what it was going to do is parse those GuardDuty findings that match our filter. In step number 4, any of the IP addresses associated with this communication are going to be put into a DynamoDB table as a kind of our temporary interim step for tracking which IPs we want to block. And then in step number 5, we're going to have another Lambda function, which will create rules both inside of our WAF for blocking any communications to our web application endpoints. But along with that, we will have similar rules that are sent to our network access control list, which you see as that other arrow there. So network access control list, sometimes called a NACL, is a mechanism for blocking traffic within our VPCs. So not only will we be blocking traffic going to our application endpoints, but we'll also be blocking any communication in our private VPCs to these IP addresses. And then in step number 6, we'll send a notification email via Amazon SNS that the workflow is completed successfully.
Great. In this example, we have a multi-vector threat that has components that are detected by different edge services. Now, a siloed view into an alert from a single service may not give the IR specialist enough information to confirm a remediation action. But taking into account the collective view of alerts across multiple services, we can now tell the IR specialist what was detected with a high degree of fidelity, and they can now confidently take a response action to that alert. Michael, anything to add on this one?
Yeah, so what we're highlighting here is AWS Firewall Manager to have viewpoints across all these different range of services. All those services you see there on the left are services that can be managed by AWS Firewall Manager. And then any sort of findings related to those services can then be aggregated and sent over to Security Hub. Security Hub itself has integrations with other services, things like AWS Detective, as well as other third-party systems, such as you see here, PagerDuty, Jira, Slack, etc., and other ways of integrating into your operational workflow for taking action.
Great. On this next example and the final one, this is centered around Firewall Manager, but its ability to push consistent and centralized policy to the AWS Security services that you see on the bottom of this slide. And its support for third parties as well, that you can see to the left of the slide, and integration with Security Hub for the monitoring piece on the right portion of the slide. Anything to add here, Michael?
Yeah, so in addition to AWS Firewall Manager having capabilities for managing all of these AWS native security services, we also have integrations with third-party security services from Palo Alto, Fortinet, and Checkpoint. Those are all next-generation firewall services that operate similar to an AWS in-service in terms of their capabilities, and AWS Firewall Manager can help you in terms of both deploying them and managing them at scale. So in addition to managing them, any findings related to those services, AWS Firewall Manager is able to send to AWS Security Hub, and then integrate with some of your more common SIEMs, such as Splunk, IBM, QRadar, or Rapid7.
All right, so this brings us to the end of the use cases that we wanted to share with you. I'd like to share with you a list of resources that will provide detailed descriptions of the automation mechanisms that we've discussed with you throughout the course of this presentation. I'd like to thank you for your attention today and hope you've learned a few techniques that will allow you to better utilize AWS security services to expand the reach of both the detection and the remediation actions delivered across the security services suite. So thank you for watching.